Okay, let's just continue with this integration. So this time we have, maybe, okay, so we got that, x minus 1 over x raised to the third dx. So this one's a little labor intensive. So we want to remember that if we raise something to the third, it's going to multiply by itself 3 times, like that. And then if we multiply, we get x squared. Multiply x, and then dividing by x is going to cancel, so it's just -1. Same thing happens here. And right here, negative negative makes a positive, and now there are 2 on the bottom. All right, so we get that, but we still have this last piece on the outside. And I'm going to combine these two to just make a -2. All right, now we just need to multiply that out. So x squared times x is x cubed times that. We have 2 x's on top, 1 x on the bottom, a negative sign, so that's just going to leave an x, negative x. -2 times x is -2x. -2 times this will be positive 2 over x. And then if we do this times this, we have 1x on top, 1x on bottom, so it's 1 over x. And then this, we just have 3 on the bottom. Okay, so combine those, I get -3x. Combine those, I get 3 over x. And then I just have my -1 x cubed and x cubed. Okay, so this is still in an integral. Now, one more modification before I actually take the derivative, or the antiderivative. It's going to be easier if we do it that way. Okay, so we raise by 1, raise the exponent by 1, and then we divide by the new exponent. Raise this by 1, so we get x squared. Divide, so we end up with 3 halves. Raise to 1. Now this is a special case. I'm going to come back to that. But we're going to raise this by 1, which is going to be to -2. And then if we divide that by -2, we get something like that. Okay, now you may remember that the natural log, if we take the derivative, becomes 1 over x. And so if we have 1 over x and we go that way, it's the derivative. So this is like saying 3 over x, or 3 times 1 over x. And so this portion becomes natural log. Now natural log cannot have negative numbers, and so it's important that we say natural log absolute value of x for the derivative of this, and then we have a 3 out in front because of the 3. Okay, let's clean this up just a little bit. So this one's fine, 1 over 4x to the 4th. This one's also fine, -3 over 2 x squared, and then that's plus 3 natural log absolute value of x. And then the negative in the negative becomes a positive, and then I'm just going to put my x on the bottom because it had a negative exponent. And then don't forget your plus c, because we took an antiderivative. All right, that was pretty long. Now let's keep going. So we have 3 square root of x plus x squared over x dx. Okay. So when we're doing this, we need to divide each piece by x. So we're going to rewrite it like 3x to the negative, not negative, x to the 1/2 plus x squared. Then we're going to write each one over x. So we kind of broke it up. Okay, now we think of these having exponents of 1. So 1/2 minus 1, that's going to be 3x to the negative 1/2. And then that's just going to be an x. So really the key to a lot of these is just writing them in a form that makes it easier to deal with. So if we raise this by 1, we get x to the 1/2. And if we divide by that new exponent, that's the same as multiplying by 2. So we have 2 times the 3 that's already there. Raise to a 2, divide by 2. So that's going to be 6 square root of x plus x squared over 2 plus c. Okay? And that's it for this video. If you need additional help, come to MathLab. Until then, calculator.